Okay, metallic bonding is a special type of bonding that occurs between mostly transition metals. And what it is, it's a special type of electron sharing. Because these transition metals have what we call valence electrons in the d orbital, they tend to be delocalized. And what that means is the electrons are kind of shared between all of them. Okay, a lot of times it's called what we call a sea of electrons. It's it's kind of a poor analogy for what's going on, but because of the energy, the d orbitals, an electron in this atom could be shared with this one, or it could be over here, or it could be over here. In other words, there's no real way to define uh, who the electron belongs to. So it's sort of shared by the community, and we call that electron communism. It's one in which there is no ownership of a particular electron. Instead, it's kind of shared amongst all the protons that are there. Now, a couple of properties that deal with metallic bonding is the delocalized electrons allow electrons to move freely through it. In other words, because of that, an electron can come in, it can be transferred, it can go to the next one. And the reason for that is because of this delocalized shell. They're used to electrons coming in and out. As a result of that, most transition metals tend to be electrically conductive. In other words, they will allow electricity to flow through them. A second property is that they tend to be thermal conductors for the same reason. Because electrons can be moved through the atoms so easily, they can actually transfer energy to the atoms via the electrons as well, and so as a result, they tend to be thermal conductors. They also tend to, because they can slide past each other real easily in terms of the protons moving about in the sea of electrons, it tends to be easy to reshape these metallically bonded atoms, and so that results in these things being both malleable and ductile. Now, remember, malleable means it can be pounded into very thin sheets, and ductile means it can be taken and drawn into very, very thin wires. So this example says, using the description of metallic bonding, explain why solid metallic bonds can change shape easier than solid ionic compounds. And the reason is it all has to do with the attraction between the positive and negative charges. Because this is such a great attraction between the two, it's very difficult to move these things away from each other and kind of create a smaller, thinner shape, or to pound them so that they separate because it's such a great attraction. Because of the delocalized nature of the electrons, if I take this proton and I move it over here, well, there's electrons over here to be able to make it stable. If I were to take it and move it over here, there's electrons over here to make it stable. What it does is it minimizes the repulsion between these two nuclei. They don't feel it as much because there's electrons in between that can kind of balance out that repulsion between the positive charges.